Welcome to our program, Astronomy for Everyone. The topic for this month's show is the Rosetta Mission, and to tell us all about it is our own Stephen Whitty. Stephen, welcome back to this part of the program rather than just the parts that you usually do.
Yeah, well, thanks. It's good to be here.
Yes, indeed. Can you tell our audience about the Rosetta Mission and the places that it's going to?
So a lot of these missions, these are space missions, you think of them as NASA missions. This is an ESA mission, a European Space Agency mission. And it's been, it launched quite a long time ago. It's been in progress for some time. So it actually launched in March of 2004. So
we're 10 years at this point.
That's right, we're 10 years into it, yeah, more than 10. And it had kind of a tortured set of orbits that it had to go through in order to get to the comet, which it just did recently. And so it did a flyby, it was launched from Earth. It did a flyby of Mars. It went back to Earth to do a flyby of Earth to get some more speed. It then passed 2 asteroids and finally has made it out to the orbit. So this is only part of the mission you can see on the image right now. So it was Earth in 2005, Mars in 2007, Earth again in 2007, and then asteroid Steins in 2008, and then Lutetia in 2010. So all of these things were kind of interesting stuff. We had an image just a second ago of the comet itself as seen from Earth. Yeah. All right. So you're not actually looking at the nucleus of the comet here. You're looking at mostly the coma, the dust and the gas and stuff.
Exactly.
But so we used a really big telescope.
How big was it, Steve?
Yeah, so it's this is the VLT, the Very Large Telescope in Chile, which is also an ESA sponsored telescope system. There are 4 big telescopes. They probably just used one of them, but it's a really significant telescope, and that's really pretty much what you got for a comet picture from it. So you don't actually know what you're going for. You don't know what's at the destination. But on the way there, they did get to asteroid Steins, and they did, which we should, yeah, so here's Steins. It's a little fuzzy, and it really is a little fuzzy even on the computer. This was the best picture that I got. So Steins, they had gotten they didn't get that close to Steins. I thought I had a distance here. So this is a 5-kilometer, maybe 3-mile diameter, if you want to call it a diameter. It's not really round. Asteroid. So it's pretty big, and you can see that there are craters on it. There's, and it has a spin and all of that other stuff. There's this big crater on the top there, and it's 2.1 kilometers across, right? So it's a good fraction of the size of the whole asteroid. And when geologists looked at that, they said, well, it's amazing that the telescope is still together. The asteroid is still together after getting hit.
You'd think it would have blown apart.
Yeah, you would have thought that would be the end of it. But actually, quite a few asteroids have really big craters on them for the ones that we visited or imaged with radar. So that's actually fairly common. Vesta, which is, is it an asteroid or is it a dwarf planet? The south pole of Vesta is a big crater, right? It's huge, absolutely huge, and people talked about that as well. So
this was the first of the 2 asteroids that Rosetta went past?
That's right. And then it was quite a while, but it made it by Lutetia, and Lutetia is also a pretty big comet. Lutetia is a Roman name. It's kind of weird. It's a Roman name, and it was picked because the guy who discovered it from his balcony in Paris, and Lutetia is the Roman name for the city that was where Paris is.
Where Paris
is, that was called Lutetia. So, so that's where this asteroid gets its name. So they didn't have anywhere near the light pollution in 1852 that we have now. So you could just do it from downtown Paris, no big deal, right?
Gas lights didn't present that much of a problem.
That's right. That's right. Lutetia is much bigger than Steins. It's 100 kilometers so 60 miles across.
Substantially bigger.
Yeah, really substantially bigger. So we don't want something like this coming near the Earth. I don't know what we would do about it if it did. We would be in deep trouble. Anyway, so that's Lutetia. So finally, this past August, so August of 2014, Rosetta makes it to the comet 67P Churyumov-Gerasimenko, right? It's a real mouthful, right?
Yes, it is. It's easy for you to say.
Yeah, absolutely. Yeah, so that was not my best rendition of it. I did listen to Europeans actually pronounce the name of this comet multiple times, and I practiced like crazy. So 67P, that's the easy part. 67P, Churyumov-Gerasimenko.
I think I'll stick with 67P.
Yeah, that's fairly safe. Yeah, it also works in Twitter because in Twitter you've got limited space, right? So 67P is a lot shorter.
Indeed.
Yeah. So some of the first things that once we got a picture of the nucleus, because Rosetta is now in orbit around 67P, and the nucleus is 2.5 kilometers in diameter, and people don't know what kilometers are anyway. So, all right. So you say, well, it's 1.5 miles, or maybe it's 1.75 miles, right? But people don't get really a good feel for what that is. So a number of pictures were published where they basically took one of the brand spanking new pictures of the nucleus, and they put them, they superimposed them near big cities like LA is one, and Toronto is another one. So this first one, I believe, is Toronto. So that's, this thing, it kind of looks like a horse in this picture, but the first pictures that I saw of the comet, it looked like a rubber duck, and somebody even painted one yellow. It was pretty funny.
Oh, gee.
It was, that was in the bathtub. Anyway, so if Toronto actually had this comet in this position, right, and it had fallen there, then it would be moving at 25,000 miles an hour, because that's the minimum speed. It would probably be going much faster than that, but that's the minimum speed. And, Toronto would be toast, but also much of North America. It would be a really bad day for everybody. So, and then there's one with Los Angeles. So the same sort of deal. You get a scale. You get a scale comet.
Oh my!
And where's Los Angeles? Los Angeles is a big city, just absolutely humongous. The big buildings are kind of concentrated, but it just sprawls and sprawls.
And I think you were telling me if something this size were to hit New York, Boston would be
Boston
toast
would be
as well.
toast. Yeah. Washington D.C. too. All of that stuff. Philadelphia would be in trouble.
Oh my! Yeah.
All of that stuff. So yeah, it turns out that anyway. So this comet, it has this orbit that is it comes fairly close to the Earth. That is, it comes within a third of the distance from the Earth to the Sun from the Earth. So its orbit,
close.
Its orbit actually comes within, what would that be? That would be 30 million miles or something.
Yeah.
Okay. And it goes out to slightly past Jupiter. So the comet was discovered in 1969 by presumably two Russians, because when you have a name like that, it's usually two guys.
Like Hale-Bopp was
exactly, Hale-Bopp. But Wikipedia talks about Churyumov and his discovery of it. He was looking at the plates. He was looking for another comet, and it turned out to be really faint. It was on their plate, but it turned out to be really faint. But this comet was really quite obvious, and he mistook it for this comet he was looking for. And it was a month before he figured out his error. Anyway, so he says. So anyway, he discovered it, and then it was the orbit was pre-calculated back to 59, and it turns out that it had an encounter with Jupiter, which changed its orbit. It never used to come as close to Earth.
Oh, okay. So, well, this is really quite interesting. We're going to take a quick break in our discussion about the Rosetta mission to Comet 67P. If you have any questions, please send them to our email address, the address which you can always see at the bottom of your screen to ask us questions about this show or any other show. And right after term of the month, we will be back with more discussion of this very interesting European Space Agency mission.
Thanks, Don. The term of the month for October 2014 is C/2013A1 Sighting Spring. That's a comet. So we've got a kind of a comet theme going here. On October 19th, this comet is going to pass within 83,000 miles of Mars, which is really great. We've got a flotilla of orbiters and a couple rovers at Mars. So the Mars Reconnaissance Orbiter, seen here in the clean room, the Mars Odyssey, artist rendition in orbit, MAVEN, ESA's, that's the Europeans, MEX, the Mars Explorer, they're all going to be in orbit, and ISRO's, that's the Indian Space Organization's MOM, Mars Orbital Mission, they'll all be in orbit by the time the comet gets there. And the comet is going to spray, we think, 0.5 millimeter bullets at 126,000 miles an hour at everything. So the general safety idea is to put the orbiters on the opposite side of Mars when it happens. Use Mars as a shield, and that should be good. The American NASA missions and the Europe missions have already move their spacecraft so that when the time comes, they'll be in the right place. The Indian Space Agency hasn't said exactly what they're going to do yet, and they're just approaching orbit, so I think they're going to wait and see how the orbit goes. The rovers, Opportunity and Curiosity, that are on Mars, they're going to be fine. The atmosphere will protect them. So they should get a good meteor shower that they can take a look at. So there's Opportunity, and then this is Curiosity. The orbiters will get to do lots of science while they're there as well. So that's the term of the month, Sighting Spring, for October 2014.
Thanks, Steve, and welcome back to the show. We're here with Stephen again, talking about the European Space Agency's Rosetta space mission. You wanted to get back to the Rosetta orbiter for just a moment?
Yeah, that's right. So we've got this orbiter, and on August 3rd, it made it to within 100 kilometers of the comet. So the orbiter, the mission has really two spacecraft. One is Rosetta proper, and then there's a lander. There's a submission, if you will. There's a smaller chunk that comes off of the main Rosetta mission, and it goes down to the nucleus and lands on the comet.
The surface of the comet. Yeah?
So we have the Rosetta Amphilia. There you go. So this is the portion of the mission that actually will land on the comet. So this part, the Philae, has solar cells on it, not big solar panels, but solar cells on the actual, all the way around. But it also has batteries in it. All right, so the idea is that, well, they would like to at least get a couple weeks out of it so that they can, you know, take some pictures and take some measurements and stuff like that. But they would actually like it to, you know, if it survives, they would like it to continue doing science, perhaps as late as March of 2015.
Interesting.
And in March in 2015, you think, well, you know, if it's got solar cells, then what's the big deal? Why not go on forever, right? But the orbit of the comet of 67P is elliptical, and it, you know, it's way out, you know, by Jupiter, and then it goes way in almost to the Earth, and it is thought that it will be too hot for Philae by then, and it will probably be cooked. So that'll be the end, probably, they think, or at least by design, somewhere around March.
Okay.
So, so in August and in September, they made a number of landing site choices, right? So what happens is the science teams and the engineering teams get together and they say, well, the science teams say, well, you know, if we're here, then we'll have a good look at these bits of the comet, and from what we know already, we might be able to use this, that, or the other instrument to learn this, that, or the other thing. So they have a number of landing spots. So we have AC and what was it? It wasn't D, but A and C. Anyway, we have an image with A and C on it. So these are two of the candidate places, and then we have another picture with A, B, I, and J. There you go. Yeah. So those are mostly on the body, although J turns out to be on the head. Anyway, so but just before we taped the show, it turned out that they came up with a final choice, and it turns out to be J, and J was picked because with C as a backup. But one of the instruments, the scientists said, you know, if we land on C, we're completely out of the mission. And then they thought, oh well, you know, maybe if we landed on C from the right angle, right? So they get engineering in, and you know, to guide it in at the right angle, at the right speed, etc. Maybe it won't be a total failure for them. Anyway, so J seems to be the best pick, and from an engineering perspective, this idea, this is the J, is really on the head of the rubber duck, or some people say the capybara, and then this is a zoom in on J, site J. There's a great 3D, so you take two pictures and you do the red, blue, or glasses, or you do cross your eyes, and there are several ways of doing these. There's also a flash GIF that you flash one image and then another image, and it gives you kind of an idea that it's
3D.
Anyway, when I was looking at these 3D things, and you can actually look at this, the Planetary Society has it. If you look for Planetary Society, Rosetta, and landing site, or Philae, actually. So you'd have to spell that, Philae. That should get you to Emily Lakdawalla's blog, where she talks about it, and she's got a bunch of these 3D things. So, and you can pick one that will work for you. Anyway, when I looked at it, it didn't look at all smooth. This is the smoothest of the landing sites. The engineering team estimates that they've got a 70 to 75% chance of actually landing on this thing properly.
Okay, so that's the trick, to land properly so they can do the science.
So they can do the science.
Which is important, because in the time that we have remaining for this, I guess the question is, this is only one comet. Even if they land correctly, what can we learn from just one comet?
Well, they've already learned quite a bit. They have radar, so they can actually look into the comet. When Philae lands on the comet, they can do seismology, and not only can you figure out the structure of the comet, but if they last long enough, if they last till March, there's a decent chance that as you know it starts doing comet-like stuff, and you've got gases and dust and all that, you might have comet quakes, and that might be interesting.
Interesting. Yes, yes.
They're going to be measuring magnetic plasma. Of course, they've got cameras all over this thing, and so when Philae lands on this thing, one of the things that they've made a big deal about is that there are these two harpoons that will try to hold the lander onto the comet. There's not much gravity.
Okay.
But they're also 3 feet, and they're going to try to screw into the comet with little screws. Anyway, but the whole unit can turn around in circles and image places, so they're going to be looking in infrared and visible. They're going to do a spectroscopy so they can figure out materials. They're going to dig into the comet, pull it out, and then analyze the samples. And they're going to be looking at the chemistry in quite a bit of detail.
Well, this sounds like a really interesting mission. If folks would like to get some more information, please check out our website. Like the email, the address is down at the bottom of your screen. Steve, I want to thank you for taking the time to research this mission. I had no idea it had been this ongoing for such a period of time. I thought it was much more recent. And so I do appreciate you bringing this information to our viewers. Coming up next, we will have What's Up in the Night Sky with Stephen Weddy. Thanks for watching, folks. We'll see you on our next show.
What's up in the night sky for October 2014? At the beginning of the month, the sunrise is at 7:30 in the morning, but by the end of the month, it's 8:05, and the sunset is at 7:15 p.m. At the beginning of the month again, and by the end of the month, it's 6:30 p.m. So the days are getting shorter. They're getting quite a bit shorter. And so it's darker longer at night. I love fall because the nights come on earlier, so you don't have to stay up as late, and yet it's not freezing cold like it can be anyway in the winter. But it can be colder than you might expect, so keep warm, dress warmer than you expect it to get, right? Because you'll probably be surprised, especially if you're just standing there or sitting there. The moons in October starts with a first quarter moon, right on the 1st of October. And then on the 8th, we have the full moon. On the 15th, we have the third quarter. And it's always a week later, you know, for each of these quarters. On October 23rd, we have the new moon. Now, in October, if you look straight overhead around 10 p.m., you'll see the constellation Lacerta. Now, Lacerta is not a big, bright constellation. It only has a couple stars. But it has a whole bunch of constellations that dominate the sky around it. That includes Cygnus, you know, the big Northern Cross, the Swan, Pegasus, the Great Square of Pegasus, Andromeda, which looks like a V coming out of Pegasus, Cassiopeia, the W, and Cepheus, which looks kind of like a house. And my favorite object in all of these places isn't in Lacerta, it's actually in Andromeda. M31, the Great Andromeda Galaxy, is the brightest galaxy you can see in the sky. If we look at an Ori, that is, if we look at the solar system from solar north, or which is also Earth north, everything is moving around the sun counterclockwise in this image. If you draw a line from the sun through the Earth and out, then anything sort of below it and then down to the left, those are things that you see in the evening. So I've got this drawn out to Jupiter with more or less the direction of Saturn and Pluto and Neptune and Uranus indicated just by arrows. So anything that is above and to the right, that's Jupiter, those things are in the morning. Now, if you look, the Earth has Mercury directly in front of the Sun, and Venus is right behind the Sun, and so you won't be able to see either of those. So we start the planet roundup with Mars. And so we have Mars and Saturn. Mars is in the constellation Ophiuchus. It sets around 11 p.m., so you need to see it, before then. I think it might be best right around 8:30, so the sky is dark and Mars will be pretty bright. Saturn in Libra sets around 11 p.m. also because they're very close together. I think it's best around 7:30 because it is so close to the Sun that you need to have the Sun just go down a little bit, and then you need to go see if you can see Saturn. Superior conjunction, that is when Saturn is behind the Sun, you won't be able to see it at all, is November 18th, and we're quickly coming up on it. So if you see Saturn at all, it'll be sort of the last gasp before it goes behind the Sun. So Mars and Saturn are fairly close in the sky right now, but while we lose Saturn rapidly, we have Mars almost until June of 2015, and that's because the Earth has to catch up to Mars, or actually speed away from Mars at this point. It has to pass Mars and speed away from it. Then next up, Uranus is in Pisces. It rises around 9:35, and it is highest in the sky around 4 a.m. So that might be the best time to see it. You'll need a decent finder chart for Uranus. Opposition for Uranus is October 7th. That's when the Sun, the Earth, and Uranus all line up. So that's when Uranus is brightest. That's when it's biggest in the sky. If you want to see it naked eye, that's the time to do it. Again, you'll need a better finder chart than this. Uranus is in Aquarius. It rises at 8, so it's up almost all night. It's highest around 1:30 in the morning. Neptune is even harder to see. You'll really need big binoculars or a telescope. Jupiter is in Cancer. It's the only bright thing in Cancer. I mean, the Beehive cluster is the next bright thing. It's not even a star. It rises at 4:25 a.m., and I think it's best at about 6:30 a.m. That's right before sunset. So you want to be careful if you're looking at Jupiter. Don't wait until the sun rises. And that is what's up in the night sky for October 2014.